Okay, so the X13 Whirlpool map is going to be demonstrated now. Remember what X13 or the first Fermat or Torricelli point is of a triangle ABC. It can be obtained if you actually erect three equilaterals upon the sides of ABC. So I'm going to take first side here AB, and then I'm going to get an equilateral, and I'm going to record its apex, and I'm going to repeat that for BC and CA, three equilaterals erected upon the sides of ABC. And then I'm going to do these lines to connect the apices, I think that's how you pronounce it, apices, of each equilateral to the opposite or corresponding vertex. So for example, vertex C is connected to the apex of the equilateral erected upon the opposite side AB. So you get this Sevian-like segment here, and then you get these other two, and they meet at a point known as the first Fermat or Torricelli point of a triangle, with very interesting properties that are beyond the scope here. Now, what we noticed is that if you iterate, so for example, I'm going to start from point 0 here, right? And I'm going to draw a triangle A0B. So I'm using the first side of my triangle. Oops. Let's do it again. So we're into the whirlpool iteration now, right? So I'm going to use the first side of my triangle AB with the starting point 0, okay, to compute the first iteration of an X13 whirlpool map. And what is that? That involves computing the X13 of this triangle, which would require the same procedure. You erect at least two equilaterals upon its sides, and you see where those Sevian-like lines meet, and you get X13. Now, what is the crux of this video? Let me get rid of these construction polygons here because they're immaterial. What we noticed, very interestingly, is that for this type of iteration, what you end up getting is a path, or a polyline, if you will, so a sequence of X13s that converge to the X13 of ABC. So this was the only triangle center that we noticed the whirlpool iteration, for which the whirlpool iteration does not converge to a polygon or a triangle, it converges to a point, specifically to X13 of ABC. Interestingly, if you do the reverse order X13 whirlpool map, you also get a polyline from 0 to 1 prime to 2 prime, 3 prime, blah, 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 which also converges to X13, but is of a slightly different shape. Okay? So I just wanted to illustrate this interesting phenomenon that here we have a whirlpool map based on consecutive X13s of those construction triangles, which do not converge to a triangle, but they converge, or a limit triangle, but they converge to the X13 of ABC. So you can see here for any ABC, this is the case. And for any starting location, this is also the case. All right, see you on the next video.